Hi, my name is Marcus Erlandsson and I will be presenting the OpenRISC Processor Platform. This 32-bit processor is the world's only true open source processor platform, meaning that it is using the LGPL license, which allow integration of custom proprietary IP cores. We have another video presentation that also shows a demonstration of a robotic arm that is controlled via the OpenRISC processor running Linux. Today's presentation will cover the OpenRISC processor platform and its extensive advantages. ORSOC is an FPGA ASIC specialist company helping our customers developing advanced system-on-chip designs targeted to both FPGAs, gate array ASIC and standard cell ASIC. We primarily use open source IP cores from opencores.org, and we have extensive experience and knowledge within verification and ASIC conversions. ORSOC are also the owner and maintainer of OpenCores and the lead project maintainer of the OpenRISC processor development. OpenCores is the world's largest community hosting and developing open source hardware IP cores. It provides developers with a centralized location to both develop and share IP cores. So if you're searching for an IP core or want to share one with the open source community, I strongly recommend you to go into opencores.org. OpenCores was started back in 1999, and the first project was to develop a 32-bit RISC processor. It was named the OpenRISC processor. Shortly, a lot of other projects started, and OpenCores has today more than 750 different projects. We have more than 110,000 registered users at OpenCores, and the interest is growing extremely. The OpenRISC processor is by far the most popular project at OpenCores, but we also see a lot of interest in peripherals and in other processors. OpenCores offers a wide range of different IP cores. We have more than 60 different processors today, with 67 different communication controllers, 29 different system-on-chip reference design. Using a complete hardware platform that is based on true open source provides a lot of powerful advantages. For example, low cost, long life cycle, reusability, flexibility and a powerful system. This is especially true when using an embedded soft processor. The OpenRISC platform is an open source processor platform that is built around the OpenRISC processor developed at opencores.org. The platform also includes many other IP cores from OpenCores, and together it enables us to create a powerful, complex system-on-chip design very rapidly, with all the great benefits that true open source system provides. It also allows the user to integrate custom proprietary IP cores, for example hardware accelerated, patented algorithms, etc., which is very important. ORSOC offers commercial support, and we can, with our modular FPGA board system, develop prototype systems very fast. This platform is being used in many different commercial products today within all different industry segments. The OpenRISC processor has been significantly improved and updated during the last 2 years. The OpenRISC is a classic 32-bit load and store RISC implementation with a 5-stage single-issue pipeline. It has also got a very stable and flexible hardware, meaning that it's possible to enable, disable, configure sizes on instruction and data caches, memory management units, internal DSP functions, floating point unit, power management, interrupt controller, debug unit, and it's also possible to add custom instructions. We have also updated the toolchain and the Linux port so that we are now using bleeding edge versions, which is very important both from a performance increase perspective but also from a stability perspective. We have also added an impressive debugging system that really reduces the workload during both development and verification phase. A concern that we had when we upgraded the OpenRISC processor was that how can we be sure that we haven't inferred more bugs than we have fixed? We needed a common test method that allowed us to use and run the same test cases on both the target, meaning on the FPGA, and in the RTL simulator, and in the OpenRISC architecture simulator. By writing the test cases in C, we can then use GCC to compile it, and then use GDB to download the test and execute the test, and then read back the results. Using GDB, we can also connect it to the RTL simulator via an interface called VPI, and we can also connect GDB into the OpenRISC architecture simulator. We also have a fourth debugging option, and that is to use a great open source tool called Verilator. Verilator takes the RTL Verilog code and compiles it into a clock cycle accurate C model. It is much faster than an RTL simulator, and it has also got built-in lint checks and code coverage checks. This system provides a powerful debugging system that allows us to quickly debug complex systems. Another benefit is that we can actually use GCC's regression test suite. This really increased the test coverage, since GCC's regression test suites add roughly 80,000 tests to our existing test suite. The debug system also gives us direct access to all internal wishbone buses, meaning that it's possible to write test cases that directly access the core that are connected to the wishbone bus. These are often the key benefits that are associated with using open source. License fee free. To stay competitive in the market today, every cent counts. Rapid development cycle. Since all the source code is available, this helps both during development and during debugging and verification. It's flexible and scalable. If you only use 2/3 of the internal functionality, why implement 100%? With full access to the source code, it's easy to scale down or up in functionality, providing a more efficient implementation. It's hardware technology independent. The option to easily shift between technologies provides an important tool. For example, it allows you to launch a product fast into the market, gaining important market shares, and then the option to easily shift to an ASIC when the volume increases, providing a more cost-efficient solution. Well-verified IPs. If an open source function is popular by the community, I can guarantee to you that it's more well tested than any commercial IP. Fast community support. The community is much faster providing support than going through a commercial support channel, for example, an FAE at some distributor. But none of these are actually the most important ones based on the feedback that we have received from our customers. These are the most important key benefits that our customers has identified with using open source. It minimizes the end-of-life problem. Let's take an example. If you have built a product based on an open source processor running at 150 MHz in an FPGA, you can then guarantee to your customers that you can easily redesign this product within 5, 10, 20 years from now without changing the software at all. If you're running the FPGA today at 150 MHz, you can be sure that you can run it in an FPGA in 150 MHz within 10 years. You might have to upgrade to a newer memory interface, but this is only a minor change compared to redesigning the whole software. The software costs today are around 80 to 90% of the cost of developing a product. So this guarantee saves a lot of money and resources. This also allows the customer to focus on developing the next generation of products rather than spending a lot of internal resources keeping all products alive. No technology lockup is a very important benefit. It is impossible to get good annual unit price reductions if the supplier knows that you're using IP cores that are only allowed to be used in their technology. The supplier then knows that it involves a lot of cost to switch to another technology. Reusability is also important. Having a platform that can easily be reconfigured into several different products and the ability to add and modify and improve each IP cores as required by each product. Copy security. If you're using an external off-the-shelf processor, it's quite easily to copy that product functionality. But using an embedded open source processor in combination with proprietary hardware accelerators makes it much harder to perform reverse engineering. We strongly claim that the only way forward developing hardware is to use the open source methodology. The reason behind this is very simple. For each new product or feature that is released, the complexity increases. This means that the verification cost effort needed to verify that functionality increases almost exponentially. If a single company must both take on the development cost and also the huge verification cost, this means that the product cost will be too high. One of the great advantages with open source is that the large verification task is shared with the big community. We predict that all generic and standardized functions and interfaces will only be developed as open source projects in the near future. Just to summarize this presentation, it's time that you adopt the mindset of true open source, and I really recommend you to have a closer look at the OpenRISC Processor Platform. It offers a lot of flexibility that often provides better system performance, even compared to an external processor that runs faster. If this sounds interesting, don't hesitate to contact us for more information.